Hello again. This is Make Electronics Experiments 26, 27, and 28. 25 would actually be included in the same sequence, but I didn't have the magnet wire that I needed for these three, so I did 25 separately. It's all about coils. In the experiment 25, we wrapped a coil around a screwdriver and then proved that by connecting the ends of that coil to a AA battery, we could create a magnetic field through electricity. In experiment 26, we will do the opposite thing. We will take a very powerful magnet, put it through the spool of a 100-foot 16-gauge magnet wire, and by moving it back and forth, we will be generating alternating current. And we'll show that first by flashing an LED, and then we'll insert a diode so that we only get to make a direct current, so there's only flow in one direction, not both, and a capacitor, and we'll charge up the capacitor, again by generating electricity moving the magnet up and down. In experiment 27, we're going to destroy a loudspeaker, which essentially shows that there's a coil in there and a magnet. And that's how we generate the sound through the loudspeaker. Then in experiment 28, we will use the coil to show self-impedance, show how it can actually first block and then store electricity. And we'll show it electricity going in both directions from the coil. Very interesting, all leading up to some audio stuff later on. So, stay tuned. Okay, what we have here is Make Electronics Experiment 26, Tabletop Power Generation, which is the opposite of the magnetism experiment. In the magnetism experiment, we generated a magnet from electricity. This device right here is a neodymium magnet, and it is really powerful. Let's see if you can see where that... most of it's out of the view there, but trust me, it's really powerful. Whoop, there you go. And part of the problem is that as I'm doing this experiment, the magnet's so strong that it pulls some of this stuff apart. But what we're going to do is take this 100-foot spool of 26-gauge magnet wire and move it up and down across the magnet, and eventually, we should generate electricity enough to light the LED. As I said, this thing, let's go like this. See the light flashing. It only goes in one direction because we're really generating alternating current, and the light flashes when we go down. If we reverse the polarity on the LED, it would flash on the way up. Let's do that. Take this one, put it over here. Take this one, put it over here. Try the same thing. Now it's flashing on the way up, showing alternating current, and showing that we can generate electricity from a magnet. Pretty cool. There's a second part of this experiment, which I'm about to set up. I'll be back shortly. Okay, here's the second part of the experiment. You can see my voltmeter is just kind of measuring in millivolts, you see down there. What I have here is the same coil, same magnet, and I have a 100 microfarad capacitor hooked to a diode. So the diode's going to block the, turn the AC current into DC, so it's blocking it in one direction. We're going to generate some power again. Same way, with the magnet down. Go up and down. I'm watching the voltmeter as I do this, and it's charging up that capacitor. Continuing to charge it up. Well, now it's starting to drop down. So as you see, I got up to a little over 2 volts, and I stopped generating power, and now the capacitor is draining. Pretty cool. But I still have a charge in the capacitor, because through generating the power, I charged it up, and now it's draining off. Go back to my little generator here. You saw I was just over 2 volts. So now it's generating again, and we are reducing again. So the whole idea is we showed that we could generate power by just lighting the LED, and then we showed that by putting a capacitor in there we could store power. Pretty cool. So tabletop power generation, make electronics experiment 26. Thank you very much. Okay, this is Make Electronics Experiment 27, Loudspeaker Destruction. What we're doing is a variation on what Charles suggested. I only had this cheap Radio Shack speaker to play with. I have some other cheap ones on order, but I don't have them yet. So I did take it apart. Took out this plastic cover, where you can see the magnetic coil there, which fits on there. Whoops, there it goes in. In fact, this is a magnet. You can see that it is in fact a magnet. And the two power cords going into it. So when this is functioning, the input power vibrates the activates the magnet, but vibrates the coil there, and causes vibrations, making sound. If I had to be able to show us a little more clearly, but this is the one that I had, and I wasn't too worried about destroying it. I think it cost $1.95, and I've used it a few times. It does work, by the way. Works fine for small things. So that was a little bit of loudspeaker destruction. See you next time. Okay, this is Make Electronics Experiment 28, making a coil react. Very simple. Same coil we had before, 100 feet of 16 gauge magnet wire and a spool with alligator clips attached to one end. The other ends are connected to the positive and negative sides of this LED. The two LEDs go through a 220 ohm resistor back to a push button switch and are connected to back through a 12 volt wall wart. So when we push the switch, the coil will initially block current, so one of the LEDs will flash. When we release the button, the electricity, the current that's been storing up due to that process releases, and the other LED flashes. The LEDs are oriented in opposite directions, so only one current will only pass through one at a time, for one or the other. So let's light goes on, light goes on off, on off, on off, on off. You can see. So that's the lesson. So this is the end of our 3-sequence Fun with Coils episode. And we're actually going to do something in this experiment, so this is fun. See you next time. So, that's it for this sequence of Fun with Coils. We started out before this sequence in experiment 25, generating a magnet, using electricity to generate magnetism. We then went the other way in the beginning of this sequence, experiment 26, and showed we could generate electricity by passing a magnet through a coil. We then took apart a loudspeaker, and then moved forward and made the coil react by passing 12 volts through some low current LEDs and a resistor and a push button switch, and showed how the coil first blocked and then stored current. Very interesting and will be very useful as we pass forward. See you next time.